This is lesson 107, Algebra 2, Numbers, Numerals, and Value, and number word problems. We're just going to jump right into the number word problems. And when we have a number like 496, all right, what does that mean? That means I have 6 ones, 9 tens, and 4 100s, right? This is old elementary school stuff, learning some of the numerical concepts that you've probably forgotten over the years, but it's good to kind of go over. So if we have 4 100s, dumb dog outside my window barking, it's like, shut up. 9 tens, okay, I'm not going to draw all those, and then 6 ones. So we have 1, 1, 1, 1, 1, 1, 1. And if we count these, we have 496. All right. So, and the reason that I'm going over that is just because of these number word problems. And again, sorry to say this, but you will never use this stuff, but it's good logic, good math sense to help you better understand numbers. In graduate school, I took a class just on this stuff, and it was very, very painful, but it helped me to better understand the basics so that I could better understand the actual math that I'm doing and how it's working. All right, so let's look at example 107.1. The sum of two digits, or the sum of the digits in a two-digit counting number is 11. All right, so what we're going to do, the sum of the digits in a two-digit counting number. A two-digit counting number is like 36. It's a number that has two digits, and it's a counting number, meaning it's not like a decimal or a fraction. It's when you count something, it's just those numbers. So in a two-digit counting number, we have a tens and we have a units. So there's my two-digit counting number. Now it says when I add those two, I get 11. When I add my tens digit and my units digit, I'm going to get 11. Okay, not so hard so far. If the digits are reversed, the new number is 27 greater than the original number. Okay, so let's see what we've got here. The original number is 10 times t plus u. Okay, so let's look at that. Let's pretend that that number is 36. Okay, so 10 times 3 plus 6. Okay, so this number right here is just a single digit 3. It isn't 36, it's just a 3. So like this here, if it was 36, it would be the t would be 3, the u would be 6. Okay, so again, a lot of theory here, a lot of weird stuff that you're like, whoa, this is like really kind of complicated, but it's really not too bad. Let's rewrite that. 10t plus u. That's my original number. Okay, all right, let's see what it says. If the digits are reversed, so if I took and wrote the u here and the t here, it says the new number is 27 greater than the original number. Okay, so there's the original number. The new number is 10u plus t. We switched them around. So that's the new number. All right, so how do I compare these two? What does it say about the comparison? The new number is 27 greater than the original. Well, in order for them to be equal, what has to be true? This one's 27 greater, so in order to make them equal, this one has to be 27 more so that it equals that one, right? So it's like saying we've got two numbers, 5 and 8. Well, they're not equal to it. This one is 3 greater. So if I add 3 here, now they're equal, right? So however many it's greater, I add that number to the other side in order to make them equal. So my original number then would be 10t plus u plus 27, because it's 27 less than the new one, so in order to make it equal I had to add 27, right? So there is my equation. Yay. Now what do I do with it? Now notice I made a mistake. That should be an 11, right? Up there, t plus u it says is 11. I don't know why I didn't do that, but you're probably having a hard time listening to anything I'm saying because you're looking at that and thinking, he screwed up. Alright, so now I have this equation and I have this equation. Alright, so I have two variables and two equations. Probably the best thing to do would be to take this and solve for t. Like that. Now, wherever I see a t, here and here, I'm going to put an 11 minus u in its place. So this is just substitution. So that all I have are u's there instead of t's and u's. Alright, so now I have 110 minus 10u plus u plus 27 equals 9u plus 11. Let's just keep going here. 110 minus 9u Okay, let's move this up. All I'm trying to do is solve for u here. Alright, so I'm going to get 110, add 9u to both sides. So 137, subtract 11 from both sides. 37, 27, 126 equals 18u. Divide by 18, divide by 18, and I get a u equals 7. Okay, so my units digit is 7. Now, one of the things it said is the sum of the two digits is 11. So if my units digit is 7, then my t, oh, that's where my 11 went. I just didn't write. That means my t then has to be a 4. So my number has got to be 47. My tens and my units. Added up, they give me 11. If they're reversed and it's 74, 74 is 27 greater than 47. So everything works there. Alright, let's look at 107.2 example. So 107.2 says the sum of the digits of a two-digit counting number is 9. So the sum of the digits of a two-digit counting number is 9. So it's very similar to the last one. Alright, when the digits are reversed, the new number is 45 less than the original. Okay, so the original is going to be 10t plus u, and that's my original. My new one is going to be 10u plus t, because I switched the digits around. Alright, so it says that the new number is 45 less than the original. So this number is 45 less, so in order to make it the same, I'm going to add 45 here, so then it's the same as that. Why do I keep doing that? Okay, so there's my equation, and there's my other equation, and again, if I use substitution and I write that as t equals 9 minus u, then wherever I see a t, I'm going to put 9 minus u. So here and here, I'm going to put 9 minus u. Okay, so let's do this in red. 10 times 9 minus u plus u equals 10u plus 9 minus u plus 45. Alright, so let's go ahead and simplify. Okay, and you probably are just going to do a lot of this at the same time. Okay, now I'm going to add 9u to both sides. Subtract 54 from 90, and that's going to be 36 equals 18u, and u then equals 2. Okay, now I'm going to take this and go back to the original. T plus u equals 9, or t plus 2 equals 9, so therefore t is 7. So t is 7 and u is 2, then the number that I'm looking at is 72. And that's it for lesson 107.